start talking about the mathematical background. We see about points, vectors, coordinate system, and transformation matrices. They might seem a bit too basic, but it's the first lecture anyway, and I really want you to understand the notation because we're going to use it a lot, and it has to be very clear to avoid any confusions later. Okay. So we will talk about the coordinate system, as I said, the rule of the right hand, which you have to be very familiar. Points and vectors, how we describe them in 2 dimensions and 3 dimensions. Transformation matrices, we'll see what all is about, and homogeneous transformations. Now, when you hear coordinate system, what do you understand? What is a coordinate system? How would you describe it to a 5-year-old? Sorry? As a graph. Yes. So, yeah, this thing, right? With arrows, I guess. Okay, what does this tell me? This thing, and what's special about this? So I can have a point, whatever point. Let's put it somewhere here. Okay, and I can describe its coordinates, you said. What are the coordinates? The distance from the origin. So this is what? Okay. You tricked me. What is the origin? Here's the origin, right? We all agree? Why? Because that's notation. We say, okay, that this axis, that's why I said, do we put an arrow? Points to the right, so that's like the positive side of the axis. Here's the negative, and somewhere in the middle it's my 0, right? I can put the 0 wherever I want, it doesn't matter. And the same with this axis, okay? So the origin is where the 2 axes meet basically, right? Yeah. So you're saying that the point, the coordinates is the distance from the origin. So this line here. Not really. From the axis. Okay, yes. So the distance is from the axis. Okay. So what is the distance from the axis? Let's say we take the first axis. Let's say this is the first. So what is the distance of this point with this axis? From this axis. I know it's very basic, but perpendicular lines, right? So from here I draw a perpendicular to this, and this length is the distance at this point from this axis, right? And the same with this axis. I do a perpendicular to this axis, and this is the right? So these 2 distances you said is the coordinates of the point, right? Very good. Yeah. So this point, since we have 2 axes, because we're talking on 2 dimensions, right, has 2 coordinates, 2 distances from 2 axes, right? If I had the third axis, I would have 3 coordinates, 3 dimensions, therefore 3 distances, therefore 3 coordinates, right? Cool. Now, what's special about this one? What property does it have? These 2 lines, the 2 axes. Basic property. They're perpendicular as well, right? So I cannot have a coordinate frame that looks like this. Okay? They have to be perpendicular. So that I can also draw from a point. Yeah, I could draw perpendiculars to this, but anyway. No. Maybe in another universe. Not in this one. Okay, and if I have 2 dimensions, 2 axes, both of them have to be perpendicular. If I have 3 dimensions, 3 axes, the axes have to be perpendicular to, each axis has to be perpendicular to the other 2, right? Okay, great. So the coordinate system is basically defined by 2 axes. They have to be perpendicular. Okay, and we use it to describe points their position relative to this coordinate frame. Okay? Can I have another coordinate frame on this board? No? Yes? Am I allowed to draw this here? Okay. This point in this coordinate frame has some coordinates. Are the coordinates of this point in this coordinate frame the same or different? Different. Why? These distances are different, right? Whatever. You get it. Right? Can I have another coordinate frame? Is this a coordinate frame? Or this? I don't know, whatever. This also has some coordinates on this frame. I draw perpendicular lines, and these distances are its coordinates, right? So I can have different coordinate frames, each one of them describing the same point, but the same point has different coordinates in different coordinate frames, right? That's very basic for what we'll discuss. Okay? And one more interesting property of coordinate frames, which is basically a notation, it's not strictly necessary, is that basically no, forget it. Okay? I just want to say that, yeah, these distances here, we define them in the same scale, right? So that the scale that we measure this length and this length is the same. That's pretty obvious. Okay, so in simple words, a coordinate frame is a mathematical tool. So it's nothing else than something we came up with just to help us describe the position of objects in space using numbers. Okay, something objective. Okay. As I tried to explain here, in 2 dimensions we have two axes and therefore 2 coordinates. In 3 we have 3 axes and 3 coordinates. In 4 dimensions, difficult to imagine, but it's possible, we would have 4 coordinates. Okay? And the properties are that the axes must be perpendicular to each other. If we have 5 axes, each one has to be perpendicular with all the rest. If we have 2, the same. And yeah, as I said, the length here the scale is the same here in all the axes. And that the coordinates of each point is equal to the number of axes and equal to the number of dimensions. And then we can have way more than one coordinate frame describing the same space, so the same surface, right? Questions? Very clear, right? So, as I have 2-dimensional spaces, I also have 1-dimensional space, okay, which basically a line. Now, notation is that when we have a point on any space, or either on 1-dimensional space or 2 or 3, we write the coordinates of the point as a vector. Here it's not so obvious, but if we talk about 2 dimensions, you can see I have here different points, describe the distances from the axis as coordinates here with the brackets. How we write it on paper is that P is equal to 1, 2. For instance, this point here, P, has coordinates 1 and 2. Why 1? Because this, no, maybe I should here better. Because this distance here is 1 unit, and this distance here is 2. So on the first axis, which I arbitrarily chose to be this axis here, x-axis, I have distance 1, and this one I have 2. Therefore, I write it like this. So I write it like a vector, one column vector, one below the other. Okay, equally Q would be 2, 1, R would be minus 2, 3. Okay, as I explained here as well, we can have different coordinate frames describing the same points. And you can see here, for instance, the point, this point, the same point, in the red coordinate frame has coordinates 1 and 2. while in the blue coordinate frame that the origin is here, it has 3 and 1. Same point, different point. As also, I try to point out here, the coordinate frames can also be rotated relative to each other. Okay, they might have the same origin, but they might be rotated. Okay, again, different coordinates. Here. Now, 2 dimensions is boring and robots work in 3 dimensions, so we'll jump directly in 3 dimensions. So in 3 dimensions, obviously we need 3 axes to describe each point. And you can see here an example of a set of 3 axes. What you will see also throughout the course is I try to use blue for X, green for Y, and red for Z. So it's trying to build like visual notation as well. And we can see here a point P has coordinates Px, Py, Pz, which is basically these distances here that you see with color. Okay. Now, one thing we should mention now, so that you keep it in mind for the whole year, is okay. Here it's pretty obvious how I designate names for the axes. Okay, I have 2 axes, so I have usually I put x, y, or it can be x and this y, doesn't matter. Okay. But in 3 dimensions, we have to be a bit careful how we designate which one is x, which one is y, and which one is z. Usually, that's again our own notation, like all humans. And do you know how we assign which one is x, y, and z? Any idea? Ever heard of it? George?
The right hand rule.
The right hand rule. Okay. The right hand rule. The rule of the right hand, or the right hand rule. Okay? Ever heard of this before? Basically, our right hand allows us to make sure that we get the order correct. Okay? There are different ways to do this. Here on the drawing, it says that if X is my index finger, and Y point and my middle finger points to Y, then my thumb will show me where Z should be. Okay, so I make the coordinate frame correctly. Okay, if X points there and Y points towards the board, then Z has to point upwards. If X points towards there and Y points towards you, then Z has to point downwards. Okay, so that the coordinate frame is correct. If X points upwards and Y towards the board, then Z has to point towards them. Okay, you can see it here as well. I hope I made it correct. Another thing as well with the slides is that when you see like a line like this, diagonal, it means it's coming out of the screen. Okay? Because otherwise this wouldn't be perpendicular. I cannot draw a line out of the screen, unfortunately. But when you see it like this, it points out of the screen. When you see the arrow upwards, then it means it points towards the screen. Okay? So here what do we have? We have X pointing outwards. Right? Y points to your right. Therefore, Z has to point upwards. Right? So make sure you get familiar with this. We're going to play a lot with it, and you're going to use it at your exam. So don't forget your right hand home. Because at the exam, I always see students doing like. So don't forget it. Always bring it. Okay? So going back to the point, since we might end up with this situation where we'll have too many coordinate frames describing, we need to give names to the coordinate frames. Okay? And we also need to use the name of the coordinate frame when we describe the coordinates of the point. Since each point has different coordinates and different coordinate frame, I need to know which coordinate frame are these current coordinates that I'm talking about. Okay? So let's call this coordinate frame O or 0. Okay? We usually give numbers for coordinate frames, like 0, first, second, 1, 2, 3, and so on. Therefore, this point, if we want to express the coordinates of this point in this frame and not in another frame, we have to give it coordinates. We have to write here with a super subscript 0. Okay, so that's how I write. So, for instance, here, if I had 1 coordinate frame 0, coordinate frame 2, coordinate frame 3, maybe let's keep it to 2. Okay, let's say 1 and 0. Okay, and points. So this point has some coordinates at 0. So let's say P0 is 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, 7. But the same point in this frame, P1, so the same point P, but in frame 1, has, I don't know, 12 and 15, whatever. Okay? So the notation is this thing here, which shows me in which frame am I, which frame do these coordinates belong to. Okay, clear? Good. Do you know what's a vector? What is a vector? Yes. A vector is a point, is an arrow, let's say. Okay, so this is a vector. This is another vector. Okay? We're going to use vectors as well. And basically, for the vectors, we can use the same notation as for points. Usually consider vectors starting from the origin, so from the 0, 0 point, 0, 0, 0, and going to a point. So a vector with coordinates px, py, pz would be an arrow connecting point 0 and point with these coordinates. Okay? And again, we use the same notation with the subscript saying, okay, that this is expressed on, this is V0, expressed on coordinate frame 0. Okay? Now, I might have more than just one vector when I'm playing around. We usually have 3 vectors. We'll see which 3. Okay? And again, another notation is that I can group the vectors together. So let's say I have, now I'm working in three dimensions. I'll do it here as well. Let's say I have a vector here, some coordinates, and another vector here. Write it, yeah. Each one would be, I don't know, let's call this V. This is coordinate frame 0, V0, and let's call this, I don't know, K0, whatever. K. Let's say V0 is this one and K0 is this one. I can put them together and make like a mini matrix. Okay, so this is like 2 vectors together. And then I have like a small matrix of 3 lines and 2 rows. Okay. What we usually do is we do 3 vectors together. Okay, where I have 3 points. Okay, and what are 3 vectors together merged in the center? Basically, this is how we describe coordinate frames. Okay, same way I have this coordinate frame with the black lines here. I can have another coordinate frame with the red lines here. Okay, in the same origin as this one. Okay, and that's how we describe a coordinate frame as a set of 3 vectors. Okay. to make it a bit more clear with one specific example, let's see how can we write this matrix here, a 3 by 3, for one specific vector. Let's say I have these three vectors, the red lines, expressed on the coordinate frame on the black lines. Okay, so here I would have this. Okay, we have another color. Let's try with blue. Okay, and I have the first vector here, the second vector here aligned exactly, and the third vector here. Okay, so how could I write, and this is coordinate frame 0, how could I write these three vectors as one matrix? What would be, let's say this is my x, maybe this is my z. What are the coordinates of the first vector? So let's call it b1. b1, 0. What are the coordinates of this frame, of this vector in the white frame or in the black frame there? Huh? Louder. Louder. So this point here, okay? Sorry? What do you mean unit? Unit vectors. Yes, they're unit vectors. Forgot to mention. So this has 1, 0, 0, right? So let's call this V1, V2, V3, 0, V2, 0. So what is the V2, 0? 0, 1, 0. You can see it on the screen as well. And V3 would be 0, 0, 1, because there's no distance from x and from y, and here it's 1. Okay? So if we put together these three vectors, what do we get? A matrix. Which matrix? The identity matrix. Okay? So a coordinate frame, basically the blue vectors, expressed in another coordinate frame, the white vectors, it's a matrix. It's a 3 by 3 matrix. In the case that the two coordinate frames are the same, it's the identity matrix. Okay? Let's see one more example. X, Y, Z. And let's say I have V1, 0, and then this is, or maybe let's make it easier like this. I'll leave it like this. V1, 0, and then this is 45 degrees. V2, 0, and this is 45 degrees. V3, 0. Do you see it clearly? So it's basically the same as this one, but rotated by 45 degrees. And again, unit vectors. So what are the coordinates of V1, 0? This one, on the white one. 1, 0, 0, it didn't change. Now, what are the coordinates of this one? 0. So it's this distance here, right? And this distance here. If this is a unit vector, then this is square root of 2. If this is 1, this is 45, then this is the same as this, so I have 2 times, I don't know, a. So I think it's 1 over square root of 2, right? So it's 0 and 1 over square root of 2 and 1 over square root of 2. I put too many zeros. Right, because this is the same as this. And this one is, what are the coordinates of this? What is this distance? It's 1 over square root of 2, so 0 again, 1 over square root of 2, but minus, because it's on the negative direction, and 1 over square root of 2. Okay, so if I put these 3 together, I will get this 0, 1 over square root of 2, minus 1 over square root of 2, 0. So this would describe the blue coordinate frame in the white coordinate frame. Okay, because these 3 vectors, these are the coordinates of these 3 blue vectors on the white coordinate frame. You will see more structures later on what's going on. Okay? The idea is that now we can see that 3 by 3 matrix describes one coordinate frame on another coordinate frame. Okay? And here we get some numbers which relate to the position of these 3 vectors on the fixed coordinate frame. Now, let's go back to 2 dimensions for a second, and then we're going to take a break. Or actually, maybe we should take a break now, before we move on. Shall I take a break? Yes, let's take a break. 10 minutes.